You know, there's this technology that sounds like it was ripped straight from the pages of science fiction, but it's actually becoming a reality right now in labs all over the world. It's called quantum sensing, and it's about to let us measure our universe with a kind of precision we've, well, only ever dreamed of.
So, how do we even begin to wrap our heads around this? Well, think about the sensors that are already all around you, in your phone, in your car. They measure the world we can see and feel, right? Things like temperature, motion, pressure. But quantum sensors, they're playing a completely different game. They let us listen in on the world's hidden secrets, those tiny whispers of the universe that have always been there, just completely invisible to us, until now.
And look, this isn't just some small upgrade. We are talking about a whole new era of measurement. It's a leap that takes us way beyond the limits of the classical technology we've relied on for centuries.
So what's the real difference here? A classical sensor, say a thermometer, it measures a big picture property, like how much a bunch of liquid expands with heat. It's a bulk measurement. A quantum sensor, though, it harnesses the incredibly weird behavior of a single subatomic particle. It's like using one single perfect atom as a probe to detect the faintest whisper of a magnetic field or the tiniest little tug of gravity.
So you're probably asking, okay, how on earth does that actually work? Well, it all boils down to a couple of key principles from the bizarre world of quantum mechanics. These are the essential tools that make this entire technology possible.
First up is something called superposition. The easiest way to picture it is to think of a spinning coin. While it's in the air, spinning, it's not heads and it's not tails, it's kind of both at the same time. A quantum particle can do that, exist in multiple states at once. And this is what makes it so incredibly sensitive. The absolute tiniest disturbance from the outside world is enough to make that coin fall one way or the other. And by seeing how it lands, we get a measurement of unbelievable precision.
And then we have the second tool, entanglement. This is where things get really, really weird. You can link two particles together so that they share the exact same fate, no matter how far apart they are. What you do to one instantly, and I mean instantly, affects the other. For sensing, this is an absolute game changer. It lets us link a whole bunch of our little atomic probes together. They all work in unison to create a much stronger, clearer signal that just cuts right through all the background noise, hitting a level of accuracy that classical sensors could never even dream of.
Okay, so that's the cool science part. But what does this actually mean for us, in the real world? Let's take a look at how these quantum tools are already being used to build applications that are completely rewriting some major industries.
First up, let's talk about something fundamental to our modern lives, navigation and timing.
We all rely on GPS for pretty much everything, right? But it has huge blind spots. It doesn't work deep underwater or underground, and it's vulnerable if the satellites go down. Well, quantum sensors can measure tiny shifts in the Earth's gravity to give you pinpoint navigation anywhere on the planet with no signal needed. And believe it or not, you're already benefiting from this tech. The atomic clocks that our entire digital world runs on, from GPS to the stock market to the internet itself, those are quantum devices, and they are so precise they won't lose a single second in over 300 million years.
Now let's get a bit more personal and see how this could spark an absolute revolution in medicine, letting us see inside the human body like never, ever before.
This is where the potential just gets staggering. I mean, imagine a sensor that doesn't just map general brain activity, but can actually detect the faint magnetic whisper of a single neuron firing. Or how about watching a specific drug molecule attached to a cell inside a living person in real time? This isn't just a slightly better MRI. It's like going from a blurry satellite map of a city to a live street view of a conversation happening on a park bench. This could let doctors spot diseases like Alzheimer's at the cellular level long before any symptoms show up.
Okay, so from the microscopic world of a single cell, let's zoom all the way out to the entire planet right under our feet.
Because these sensors can pick up on incredibly small variations in gravity, you could fly a drone over a field and create a perfect 3D map of everything underneath: hidden reservoirs of water, valuable mineral deposits, maybe even ancient ruins, all without ever digging a single hole. It's basically like giving geologists and archaeologists X-ray vision to see deep into the Earth.
And beyond all these practical, world-changing uses, quantum sensors are also becoming the tools we use to ask the absolute biggest questions we have about the universe itself.
You remember when scientists first detected gravitational waves, actual ripples in the fabric of space-time? They did it using some of the most sensitive instruments ever built. Well, the next generation of those detectors will be powered by quantum sensing. These are the very instruments that will let us push Einstein's theories to their absolute limits, and maybe, just maybe, help us finally track down that mysterious stuff we call dark matter.
Now, as incredible as all this sounds, we have to keep a balanced perspective. This is incredibly powerful technology, for sure, but it's still very much in development, and there are some major hurdles to overcome on the road to a full-on quantum future.
So here's the fundamental catch. The very thing that makes these sensors so powerful, that extreme sensitivity, is also their biggest weakness. A delicate quantum state like superposition can be completely wrecked by the tiniest vibration or a slight change in temperature. So the real engineering marvel here is figuring out how to build devices that can shield these fragile states from our noisy world while still letting them listen to it with perfect clarity.
When you boil it all down, it really comes back to this one idea. This quote just captures the whole mission perfectly. We are literally learning to harness the weirdest, most fundamental rules of reality itself, to build tools that can see and measure our world in ways that were, until now, simply impossible.
So that leaves us with one final and I think really fascinating question. Every single time in history that humanity has invented a new way to measure the world, from the telescope to the microscope, it has completely revolutionized science and society. So as we get better and better at this, what will we discover when we can finally measure the impossible?